Let's discuss about network performance. Network performance depends on so many parameters. We'll see one by one. First of all, one important parameter is bandwidth. Second one, throughput. So what is bandwidth? We will see. So we are going to define bandwidth for a channel, otherwise a link. So I use link and channel interchangeably. So what is the meaning of channel is it's a communication medium. That means I say optical fiber channel, otherwise copper channel. In that way, channel means through which you are sending the data. That's it. Anything can be channel. Okay, now link is nothing but we know what is link, right? When two systems are connected through some medium, then we say that there is a physical link, otherwise logical link between them, right? Now network is nothing but if multiple computers are connected, then it forms a network, right? So this is about network. Now these are the three things. Whatever it is, what is bandwidth is number of bits, maximum number of bits per second the data can go through a network or link or channel is called bandwidth. That means how many maximum bits we can send through one channel, otherwise we can send through a link, otherwise we can send through a network is called bandwidth. To understand bandwidth clearly, what we do is we should have a good imagination. Let's talk about one small example. Let's say this is your copper cable. Okay, through this your sender is sending the bits and your receiver is receiving the bits. Okay, so we can imagine that there is a logical link. Now I'm talking about bandwidth of the link. Now sender definitely will have some device called transmitter. Similarly, your receiver will have a device called receiver, isn't it? Now your bandwidth depends on these three things: transmitter's capacity, receiver's capacity and cable's capacity or medium's capacity. First of all, we start with the transmitter capacity. We'll ask, Mr. Transmitter, you are a device, right? You are a generator. How many bits per second you can generate? Example, let's say your transmitter is generating 100 bits per second, let's say. Now if your receiver is only receiving 50 bits per second, if that is the capacity, then definitely we say that though transmitter can generate 100 bits per second, it's useless. Why? If receiver cannot receive 100 bits per second, then though you send, what is the use? So we say that at that time, so this entire bandwidth depends on receiver's capacity or minimum value. Second thing, now this cable, example, this cable only permit 20 bits per second. That means in this cable allows only 20 signals per second because of its physical property. Understand? I am not talking about propagation speed or anything. I am not asking about signal speed. So we are just seeing how many signals it can consume per a second. That means when transmitter sends data, then that signals will be going through this cable, right? So this cable will have some capacity. That means for 1 second it can only take some bits into it. After that they will start flowing, otherwise they will start running like this. But before that, first of all, they should enter into this medium. So for that there will be a limit. It depends on your medium type. Is it a optical fiber cable? Is it a copper cable? And in copper also we have thick cable and we have thin cable like this. Generally thin cables allow, if you compare with thick cables, thin cables won't allow much bits. Similarly, optical fiber cables allow, more number of bits than this copper cables. That is the way finally medium also affects the bandwidth. Now example, let's say this is your copper cable, which is, let's say, very thick cable. Let's take like that. And if your copper cable allows 100 bits per second, just one theoretical assumption, that's it. We don't know really how, so I don't know exactly how many bits your actual cable takes, right? But we imagine one cable which is taking exactly 100 bits per second. Now we will see transmitter is also sending 100 bits per second. It has a capacity to give bits to this cable, but cable is also receiving it. But only thing is this receiver cannot receive 100 bits per second. So overall we can say that this entire link is having only 50 bits capacity. That means per second this link is consuming only 50 bits per second. Now what we do, usually what we do is in the implementations, we don't connect transmitter and receiver to higher bandwidth cable. That's unnecessary, correct? Because what is important, First of all, we have to calculate transmitter capacity and receiver capacity. Assume that for simplicity, your receiver can receive 500 bits per second. Your transmitter also can transmit 500 bits per second. Okay. If that is the case, now this entire story depends on your cable. Now cable can take only 200 bits per second. Then though your transmitter is very fast and receiver is very fast, useless, right? Now since it depends on your channel capacity, that is only 200 bits per second, then overall again this system can consume only 200 bits per second. That means this interface, your cable interface allows only 200 bits per second. After that slowly they will go this side, and again here your receiver will receive it. This is about bandwidth concept. Understand? Especially link. Now we'll see throughput of the channel, otherwise network, otherwise link. So what is throughput is how fast we can actually send data through a network. That means there is a difference between bandwidth and throughput. In bandwidth, how much hardware support you have to send the data through cable or anything. But here throughput is about software. That means to send the data actually there are a lot of hurdles. We will see that first. After that you understand throughput. Example, let's say you are sending some message from computer A to computer B indirectly through network. Example. Okay. Now when you are doing that, then you will be using lot of protocols. What are they, sir? One is error control protocol. Second one I am going to teach, that is access control protocol. Third one, flow control protocol. Everything we are going to use, right? That means if example data is lost, then what you do? Again we send it, correct? So effectively finally you have some set of data to send successfully from A to B successfully. Then how much time it will take? That means example you have 100 bits. Okay. So exactly 1 second you took to successfully send this data after recovery from the errors, everything. Then we say that the channel's throughput is, otherwise the network throughput is 100 bit per second. So second thing. So some other issues we will see. Example, let's say you are sending through a network, then that network might contain some intermediate computers again, or computing devices, we say switching elements. So these are the switching elements like routers or anything in the real world. Then some host is sending a message and this receiver is receiving it. Same thing. Then that packet will go through lot of intermediate computers. Then that message has to wait. Then there will be some processing time, everything, right? If you calculate all that stuff, then we are going to get throughput. Throughput is all about finally how much fast you can send actual data. That means actually you can send the data. This bandwidth about what is your capacity and how much data you are sending because of your real world complications. That is the difference between bandwidth and throughput. Let's take the analogy. Let's say this is your highway and it is a four-way road. Okay, that means otherwise there are 4 lanes. Now at a time, let's say since it is a 4-lane system, 4 cars at a time can travel. Now here this bandwidth of this road is nothing but 4 cars. Okay, now imagine this situation. There is one big robo. That robo is just keeping the cars here. These are all driverless cars. Okay, so whenever this robo keeps cars, immediately they will start traveling. So traveling is different, their speeds are different. So here your robo capacity will see, Mr. Robo, what is your capacity? At a time how many cars you can keep on the road? Then robo says that I have lot of capacity. You see, I can keep even 100 cars at a time. That is my capacity. But your road is not supporting it, right? So your road is having only 4 lanes. That's why this robo is also confined to keeping 4 cars per second. This is actually bandwidth, right? If you see the capacity of your robo, 100 cars per second. That means that robo can at a time suddenly take 100 cars and it can keep on the road, but road is not supporting. Then overall, if you see this entire system, then the bandwidth is 4 cars per second. If this road has 100 lanes, then we can say that the bandwidth of that overall system is 100 cars per second, right? So finally your bandwidth depends on your road capacity and the transmitter capacity. That already we discussed it. Now I think this is the time you understand it very clearly, right? Now we will see what is throughput. Example, let's say after 1 hour, otherwise let's say after 1 second. After 1 second, so This is, let's say, sender, this is receiver. Here, how many cars that receiver is receiving, we will see. We'll just observe. We'll ask Mr. Receiver, how many cars you are able to take it back? He said only, 1 car per second. How come? This road has a capacity of, sending 4 cars per second, right? Then why you were able to take only 1 car per second? Maybe there are lot of reasons. Some of the cars might got accidents, and they otherwise they will, some of the cars may be going back, everything, right? Some of the cars might be waiting in some of the hotels, right? So because of all that stuff, per a second your receiver is seeing only 1 car which is coming out, right? So far we are not at all worrying about the speed of the cars, so that is not involved. It's all about finally, so how speed your transmitter is working, what is the road capacity, how speed your receiver is getting the data, correct? So but there are lot of other issues to influence the throughput. So here throughput is about only 1 car per second, not 4 cars per second. What is the reason? Your actual bandwidth is 4 cars per second, but why throughput is only 1 car per second? Because some of the cars are getting accidents and they are not going. Second one, some of the cars are stopping in between and they are not going to end in that way. This is about road system. But similarly here also, when you have a computer network, what happens is, though your channel or your medium has a capacity of sending, let's say, 4 bits per second, what can happen is, in the reality, because of the software overhead, because we are sending that packets through lot of intermediate systems, that intermediate systems will stop the packets, right? They will process it, they will check errors, I mean CRC code, everything, and there will be a flow control software, everything. Because of that software, what happens is, some of the bits will be stopped in between. That's why per 1 second if you send 4 bits, then you might not get 4 bits per second. So end of the day only you are getting 1 bit per second, that is the speed you are getting. Then we say that is the throughput of the network. We can't avoid that. Why? Because in the real world all that software overhead should be required, otherwise we can't complete error control. Example, let's say that you are not checking the error control mechanism, otherwise flow control mechanism, then your computer network might not be, I can say, reliable, right? For reliability and for better execution, otherwise I can say that for a accurate execution, then your network should have all that software layers. What are they? Data link layer and network layer, everything. So because of all that software stuff, finally end of the day, how many bits you are going to get back per a second is throughput. Okay, so finally you understand what is bandwidth and what is throughput. We'll take some numerical examples and we are going to observe how to calculate bandwidth and throughput of some problem. Okay, let's see this problem. Stop the video and first of all read the entire question. A network with bandwidth of 10 Mbps, that means network's bandwidth is given 10 Mbps. That means whenever small letter b is used, that refers bits. Okay, if capital letter B is used, from now onwards you remember it's byte. So here it is megabits. Mega, from now onwards you should know mega means 10 to the power of 6. So 10 into M means 10 to the power of 6, B means bits, right? Bits per second. So that is the bandwidth. That means 10 to the power of 7 bits per second. So with that bandwidth, a network is sending the packets. Now we'll read the remaining thing. But can pass only an average of 12,000 frames per minute. Let's say this is your network, it's an abstract. So two computers are connected, that is the way we should understand. Now let's say your communication is going through this computer network. Such network, whenever I write this like kind of cloud, we don't know inside like what is the hardware they are using, everything. That means we want to hide it. But we know that this network's bandwidth is 10 to the power of 7 bits per second. Now this computer 1, let's say A, this is B, are communicating. Now but this network is allowing only 12,000 frames per minute. Okay, so that is the capacity of this network because of the software layer, everything. But hardware capacity 10 to the power of 7 bits per second. Now if only 12,000 frames it allows per second, right? Sorry, per minute, with each frame carrying an average of 10,000 bits, then what is the throughput of this network? So if you want to know the throughput of this network, first of all we'll see how many packets it is allowing per a second. So since 12,000 frames it is allowing, 12,000 into what is the frame capacity? Frame has 10,000 bits. So finally these many bits your network is allowing per minute. Then if I convert into seconds, we should divide by 60, right? So you know that. So finally 12,000 into 10,000 by 60 bits per second your network is allowing, though it has maybe much bigger capacity. We will first of all see what is the value of this one. So I can say that 12 into 12 by 60 I can write here. So otherwise I can cancel this 0 and this 0 and 6 1s are 6 2s are. Then you get here 200 into 10,000, right? 10,000 is 10 power 4 bits per second. Now if I simplify, I get 2 into 10 to the power of 6 bits per second. Then if I further simplify, 10 power 6 bits, megabits per second, right? Mbps. So finally I converted it to 2 Mbps. So throughput is this one. Now we'll see latency in the network. What is latency? Is delay. So whenever a message has to go from a sender to receiver B, then it has to go through the lot of delays. We will see one by one. The first delay which occurs is, so first of all that message has to be transmitted through the cable or channel, right? Whatever, let's say channel. Okay, I don't know the channel type, but this transmitter immediately will say keep that entire data on the channel. It depends on the channel capacity or channel bandwidth, right? So we know that. So for that it takes some time, that is called actually transmission time. So transmission time depends on the bandwidth of your channel which you are using to connect this computer to the network. Second thing, once you transmit this packet and now it starts going through this network, right? Now actually computer network will have lot of computers, right? So we don't know how many computers are going to stop that message, right? That's why that is called queuing delay. So there will be some computers which are going to stop your message, then there will be some delay, and you can assume like this. Let's say that message is going through this computer number C, and that C will take it and it will process it, again it will retransmit it, again there is a transmission time, correct? And sometimes if this computer is busy, then your message has to wait in the buffer of the corresponding computer. So that is nothing but queuing the packet. So that queuing takes some delay, right? Usually when your computer networks has a lot of routers, then routers are going to forward your packet to the destination. So that routers will cause lot of queuing delay and lot of again transmission times. Now the third factor, if you see, let's say this computer is C, this is D. Now really to send a packet from A to D, so only focus on the C to D communication. C is in Mumbai, C is one of the router and D is one of the, for us router everything is computer. So there is one computer in Mumbai, one computer in Delhi. So your message has to go through Mumbai to Delhi line, okay? That is, let's say, optical fiber cable. To go through that, definitely there is some delay. What is the delay? Your signal has to propagate, because to reach that message from here to here, that signal has to travel this distance. We can't avoid that distance, right? So distance is very important parameter. So that is called propagation delay. Finally, in this entire network, whenever you have a cable or medium, so your signals should start here and it has to go through all the channel, that means all the physical mediums. So that delay, let's call propagation delay. Of course it is very complex to calculate exact propagation delay, but in our computer networks problem, someone will give us the exact kilometers between two computers, then we can easily calculate the propagation delay. So fourth one is this one. I can say processing time. What is processing time? I will tell you. There is a similarity between processing time and queuing time. Example, let's say your message is going through a system called some temporary system, let's call router. So what this router is going to do is, it is going to decide whether to send this packet to this interface or this interface. This router is having two interfaces. For us, everything doesn't matter. What is interface, everything, how router will route, everything we will see later. Here, so what I would like to say is, this message is going through this router. Router is going to decide whether to send it through I1 or I2. Before taking the decision, maybe in the waiting, there may be other messages also. That means this router is going to route lot of messages, not only this computerized messages. So if your message is here, then there are other messages has to be processed, M1, M2, M3. Then after some time your message will get turned. So by that time you have to wait, correct? So the waiting time is nothing but this one, queuing delay. You are in a queue. After all these messages gets processed, you will be processed. But once you are processed, processing means what? Your packet, now once you get the turn, then you will be examined. What is the pattern you have, what is the logical address you have, everything based on that, appropriate interface will be chosen. That entire thing is a different thing. It's not waiting. Now you are processed under this router, so that is processing time. So transmission time is different, queuing delay is different, propagation delay is different, and processing delay is different. So these are the various kinds of delays you get in computer network. Let's again summarize it. Transmission time. Any computer want to transmit that message, any message onto the line, that is transmission time. Example, see this one, A, B, C. This is source, this is destination, a simple problem. A wants to send a message to C but through B, because B is going to be in between them. Then A has to transmit it onto the line, then it will reach here, then again B will take it, it will receive it, again it will retransmit. Now again B will send that to C, then C will take it, and since C is a destination, there is no retransmission. But here see now, so there is a transmission time at A, there is a transmission time of B, correct? So there are two delays. These are all transmission time. Similarly, see, C is also having some time, but is that once any message comes, C has to receive, right? So receiving also takes some time. That also we consider in the transmission time. Okay. So finally, so A and B or C are wasting some time, correct? Second one, queuing delay. So here there might be queuing delay. Example, A is sending a packet, B has to receive, right? But B is busy with some other processing, then your message will be waiting here, that is queuing delay. After that, processing will be done, processing time is involved. Then propagation delay is here, it is related to the cable. Now example, this cable size is 1000 kilometers. So a hypothetical situation, let's take a realistic situation, 100 kilometers. If your cable length is 100 kilometers, then your signal has to propagate through 100 kilometers. So it definitely takes time, that is propagation delay. So we will look into everything like transmission time, how to calculate, propagation delay, how to calculate, but we don't see queuing delay and processing time because it's highly realistic. That means, it depends on the real time situation. I don't know like how many past messages are really waiting at B, right? It's quite complicated when you have hundreds of computers. Now suddenly if I ask, so there is a computer called B, now what is the queue length at that computer? It's not really easy, correct? It depends on the exact situation. Second thing, it depends on the network failures, everything, software we are using, algorithms we are using. That's why at this moment we are just learning basics, correct? But there are some mathematical models like queue models, queuing models, MM1Q, that is you will be learning in stochastic processing. In stochastic processing, generally we try to model the situation, but in the real time it is, but without modeling it, it is very difficult. What I want to say is you are just learning basics, but exact situation is very difficult. Exact queuing delay is very difficult, right? But there are some mathematical tools in probability. Using the probability, we can analyze the length of the otherwise queuing delay of each packet, everything, not a problem, but it's quite complex. So please ignore at this moment. Similarly, processing time also. How much time a computer takes to process it, right? For that, what is processing here? Example, you will have a message and logical address to be examined. That means finally every message will have header. I will tell you that. So that header has to be processed and CRC will be checked sometimes, right? So there are a lot of issues. So for that, processing time is measured, right? Again, processing time is highly variable. It depends on the protocol, like what kind of protocol you are using. Example, one computer is processing like this. Whatever the packet it comes, it simply redirects. Then it will be definitely processing time will be negligible, zero. But there are some computers, they will check all the error control things like whether CRC is satisfied or not, otherwise everything. Then their processing time will be more. That's why, so these two things generally we ignore, that means we don't bother because they are highly variable. But transmission time and propagation delay are generally they are easy to calculate. We will see that how to calculate. Let's talk about transmission time and propagation time of a message. Let's begin with transmission time. Example, you have a packet of size 100 bits and we have a network, and that network allows 4 bits per second. That means in this network, so because of your transmitter capacity and your receiver capacity and your network's medium's capacity, so finally you are able to send 4 bits per second. How to understand that I will tell you. So this sender or transmitter can send 4 bits per second. If you close your eyes for a second, then this transmitter is going to send 4 signals like this, 0, 1, 0, 1. So first quarter second this signal is generated, after that this one, after that this one, after that this one, right? And one more thing you should understand, some students generally will have this question, sir, what if my transmitter generates a signal 0, okay, at first quarter second, then at next quarter second, what if another signal is generated and that replaces with 0? That means the previous signal is corrupted by this one. That means that happens only if the signal is stagnant. That means it will stop there, correct? But remember one thing, according to signal property, signal is nothing but maybe some electronic signal, otherwise some light signal. Light or anything, generally whenever you generate it, it won't stop. We can't stop it. So automatically that will keep on going. That's why. And one more thing, how much speed they will have, sir? Definitely the speed of the signals, usually whatever we are using in computer network, will have 2 into 10 to the power of 8 meters per second, otherwise 3 into 10 power 8 meters per second in ideal situation. Okay, so it's almost light capacity, light speed, 3 into 10 to the power of 8 meters per second. So such signal if you generate, after 1 second if you see, that will travel 3 into 10 power 8 meters. That means it's almost how many kilometers? Thousands of kilometers, right? So your signal can travel 1000 kilometers almost per second. I mean, I'm not calculating exact answer, but you calculate it. So it will be kilometers. Now, if you generate one signal, I mean, your let's say bandwidth is 4 bits per second. Within second, you can generate only 4 bits, right? So first quarter bit, if you generate a signal 0, then within next quarter of second, after end of the second quarter, you are going to successfully generate another signal, right? Meanwhile, the first signal will reach long distance. That's why, so there is no collision, nothing, right? So in that way, every signal will be having some space in this cable. Understand now? So there is no such problem. Now if you close your eyes for 1 second, what happens? 4 signals will be generated. First signal will be here, second signal will be here, third signal will be here, fourth signal will be here, in that way. Now again, if you have 100 bits, then within 1 second this is a scenario. After second what happens? Because signals will be propagating, then 1010 will reach this point, then within next second you will be able to generate one more signal, 1011, otherwise 4 more signals, right? So within 2 seconds you can see 8 bits into the line. So the question is, you want to send all the 100 bits, that means you just want to transmit all that 100 bits onto this rod or cable or channel or network, we can use anything. Then how long it will take? So that will be definitely 100 bits is the cap, I mean your total size of the message, but only 4 bits you can keep. Then we can do this one. If 4 bits per second to send 100 bits, then how long it will take? That will be proportionate, right? That's why formula for proportionate is 100 by 4. Simply reverse it, 100 by 4 into 1. It will be 25. So finally, if you see the formula, 100 by 4. 100 is nothing but your message size. 4 is nothing but your bandwidth. So if you divide from now onwards message size by bandwidth, you get transmission time. At any point, you want to know the transmission time of a message. There is a transmitter which is transmitting, and you know the message size at the transmitter and you know the bandwidth of that line whatever we are using, then definitely we can calculate the transmission time. We'll see one example. Let's say you have 1000 bits and bandwidth of that line or whatever it is 1 Mbps. Then what is the transmission time for keeping all that bits into this channel is the question. For that, formula is message size 1000 bits, let's calculate it, by bandwidth. Bandwidth is nothing but 1 Mbps. 10 to the power of 6 bits per second. Now if you cancel bits and bits, then you get 1000 by 10 power 6. It will be 10 to the power of minus 3 seconds. So because time, right, time will be measured in seconds. If you see here, this second will go up. So 10 power minus 3 second is nothing but 1 millisecond, isn't it? 1 millisecond. So that is the transmission time. Whenever a channel has bandwidth 1 Mbps, then how much time it will take to send 1000 bits into the line? 1 millisecond. Very less time, isn't it? Remember it. Now we'll see propagation delay. What is propagation delay? Whenever you keep a signal onto the line, then it has to travel this entire distance to reach the destination. Now how long that signal will take to reach the destination, it depends on the length of the channel, otherwise length of the communication medium, right? So in the same way, I give an analogy. Example, you have a highway like this, and the highway span is 100 kilometers. The length of the highway is 100 kilometers. Now there is a robo. One robo is keeping exactly 4 cars onto the lane because it's a 4-way lane. So now every car is going to be kept into the road, and they are all automated cars, driverless cars. Whenever they touch the ground, they will start moving. What is their capacity is they can travel 50 kilometers per second. Okay. Now again there is one more robo. That robo is, whenever that robo, what he is going to do is, whenever car comes to this end, he will pick it up at a time 4 cars per second. Now in this situation, the question is, what is the time taken for sending all the 4 cars to this side? Think about it. So we'll see that kind of problem later on. So I don't want to solve this entire problem at a time, but in this problem, first of all, I just want to talk about what is the propagation delay here. What is the propagation delay? So here robo is keeping 4 cars. Example, you have exactly 4 cars then, and he takes exactly 1 second for keeping 4 cars onto the road. Now the question number 1, how much time it will require to keep all the cars into the road? Exactly 1 second. After 1 second, so now your 4th car is on the road, correct? Now the question, forget about that time. Now let's begin with car number 1. Now when car 1 reaches this ground, it takes some time, right? It depends on robo, forget about it. But once this car touches the road, it will start moving. Then how much time it will take to reach this end? It depends on the distance, right? This 100 kilometers. It neither depends on this robo number 1 or receiver robo. It depends on the time, the length of the road, correct? Now we'll ask, Mr. Road, what is your length? 100 kilometers. Mr. Car, what is your capacity? 50 kilometers per second. Then such car really want to propagate this entire distance, then it requires 2 seconds. Now try to understand the difference between transmission and propagation. Transmission is simply keeping the car onto the road. Propagation is nothing but that traveling time from one place to another place, it depends definitely on the distance, right? But transmission depends on the circuitry and the permissible rate of that cable or road, right? This road is only allowing 4 cars, but each car, now propagation delay is different. It depends on the road distance. Now we will see one example of propagation delay. Read this question. Stop the video and read it. What is the propagation time if the distance between the 2 points is 12,000 kilometers? Now problem is very simple. There are 2 points. Maybe these 2 are computers. The distance is 12,000 kilometers. So that means very huge distance, right? Maybe you are sending signal from one computer to satellite. That is what this problem says. Assume the propagation speed to be 2.4 into 10 to the power of 8 meters per second in cable. So there is a cable between, that means it's not satellite because he said it's a cable. Maybe you are, from India to America, you are sending the signals. The question is, what is the propagation time? So now propagation time does not depend on the size of the message, correct? So we assume that already message reached this point, entire message reached this point, right? After that, your message is going to travel, right? First of all, first bit will start traveling, after that second bit, third bit, everything. So we don't worry about the transmission time, everything. We completely focus on the speed now. We know that propagation delay depends on what? The distance between the two nodes, correct? That's why we can happily calculate this with only distance and the speed. So first of all, let's take only one signal and we'll ask, Mr. Signal, you are the first bit, and how much time you take to reach this end? That is a question. That is propagation delay. So every signal is going to have same propagation delay, correct? Whatever the signal you ask, same answer it will tell. That's why now the question is, how much time a signal takes, a data signal takes to reach from source to destination? For that answer is, first of all we see the capacity of the signal. What is the speed of signal? 2.4 into 10 power 8 meters per second. Mr. Signal, if I give you 1 second of time, you are going to travel 2.4 into 10 to the power of 8 meters. I understand. But I have to travel only 12,000 kilometers. Then for that, how much time you require? See, kilometers to be converted to meters for uniformness. So it is 10 cube meters. Now problem is reduced to 2.4 into 10 to the power of 8 meters. If you want to travel, then that signal requires after all 1 second. But here 12,000 into 10 cube meters has to be traveled. Then how long it will take? Again, see, it depends on the distance and it's proportional, right? So because of the proportionality, we use this formula. Simply we take this one on top and this one on down, right? 12,000 into 10 to the power of, this is 3, by 2.4 into 10 to the power of 8 meters, right? It's just aptitude, okay? So meters will be cancelled, but meters per second, right? That second will go on top, then entire answer will become seconds. So 10 to the power of 3 and this 10 to the power of 3, 10 power 6 will be cancelled with this 10 power 8, then remaining thing is 10 square. So here remaining thing, if you take 12 by 2.4 into 10 to the power of 2, 2.45, then 5 by 10 square, 5 into 10 to the power of minus 2 seconds. That is nothing but 0.05 seconds. In that way we can calculate the propagation delay of the message. Okay, so here whenever you are calculating the propagation time, you don't require to know the length of the message or anything. You should know the signal speed. Okay, so your message is going to be converted as signals, right? Then if you know the one such signal speed, then we can find out the propagation time. See this problem. What are the propagation time and the transmission time for a 2.5 kilobyte message if the bandwidth of the network is 1 Gbps? Assume the distance between the sender and receiver is 12,000 kilometers and that light travel at 2.4 into 10 power 8 meters per second. Okay, first of all we start calculate transmission time. How to understand this question is, this is, let's say, sender, this is a communication medium or network, and this end there is one receiver which is connected. The question number 1 is, what is the transmission time? That means this sender is going to transmit the data, right? That transmission time we require. So transmitters is going to transmit the data based on the bandwidth of this network. What is the bandwidth of this network? 1 Gbps. Though your transmitter is very speed, it can't operate on that speed. The reason, it should go with respect to this network's capacity. What is the network capacity? 1 Gbps. That means 10 to the power of 9 is 1 Gbps. That means bits per second. Remember it. So we'll see now transmission time. Transmission is nothing but all that message 2.5 kilobytes into 10 cube. Byte means 8 bits. I am converting everything into bits so that calculations will be easy. So these many bits we have to keep on the network. To do that, with this bandwidth, what happens we'll see. What is this bandwidth says? Within 1 second it can take 10 power 9 bits. But how many bits you have? 2.5 into 10 to the power of 3 into 8 bits. Then how long that network will take to transmitter inject the message, right? That requires 2.5 into, we know the formula for it, correct? Simply message size by bandwidth. Otherwise use this logic. According to this logic, then it's proportionate. Whenever it's a proportionate, direct proportionate, we have to take this second component on top, that means by first component 10 power 9. That is a formula in aptitude. So it will be 2.5 into 8 is 20. 20 into 10 to the power of 3 by 10 to the power of 9. So if you simplify it, you get 2 into 10 to the power of 4 by 10 to the power of 9. It will be 2 into 10 power minus 5 seconds. So I can write 20 into 10 power minus 6 seconds, which is nothing but 20 microseconds. So that is the answer. Okay. Now we will see second part. What is the propagation delay? Okay. So propagation delay does not depend on a packet. So this is your, let's say, communication medium or network delay, correct? That means I can say that length of the cables in this entire network. What is given? This is your sender, this is receiver. Forget about that network structure, everything. But sender has to send a packet across the channel of distance 12,000 kilometers. Now finally, here it's all about how much time it will take for a message to travel from this point to this point. Correct? It entirely depends on signal speed, one signal speed, right? So every signal has same speed. We'll ask Mr. Signal number 1, how much time you require to travel from this point to this point once you come to the line. To come to the line you require some time, that is already calculated in transmission time. That is not the question here. What is the propagation time of a signal is the question especially. So whenever someone asks what is the propagation time of a message, still we have to calculate propagation time of a signal. Both are same. So we'll ask Mr. Signal, what is your speed? 2.4 into 10 power 8 meters per second, because indirectly it said light travels at 2.4 into 10 power 8 meters per second, and we should assume that, let's say, signals are light signals. So that's why that information is given, 2.4 into 10 power 8 meters in 1 second. But how much distance we have to travel? 12,000 kilometers, right? Kilometers can be written as 10 cube meters. Then how much time they will take? Is it not again direct proportionate? Whenever it's a direct proportionate, formula is nothing but flip it. 12,000 on top and 2.4 into 10 power 8 on downside into 1 second, right? Now see, meters gets cancelled. You get 2.4, 5 is a 12 actually, correct? So now 5,000 into 10 cube by 10 power 8. It would become 10 power minus 5. Now if I simplify further, it will be 5 into 10 power minus 2 seconds. So if I write it, then it will become 0.50 into 10 power minus 3, which is nothing but millisecond. So it requires 50 milliseconds. That's it. In that way we can calculate propagation time. Okay.